Hey, 7th graders, today's lesson is 1.3 Metabolism, and your learning targets for today. I can model a healthy body, and I can identify where to find necessary molecules in the human body. So for the last couple of days, we've really taken a look at some of the molecules in our food. You guys built some models of those, and we kind of started talking about what they're made up of, and when we eat them and digest them and chemically break them down into those building blocks, what does that look like in our body? So at this point, you guys kind of have an idea of where we might find things, and when we digest them, how do they break them down, especially in regards to food. Okay, so moving on to slide 2, that's your activity 1 notebook today. You guys are going to open up your OneNote, and you guys are going to add these 4 vocab words. So molecule, a group of atoms joined together in a particular way. So molecules are made up of atoms. And atoms, of course, are a little bit smaller, as molecules are a bunch of atoms put together. So it could be as small as 2 of the same atom, or 2 different atoms, or it could be hundreds and hundreds of atoms. So you guys saw yesterday when you built starch, you guys had a bunch of those glucose. Well, each of those glucose has about, see, it's C6H12O6, so about 24 atoms in one molecule. So one of those little marshmallows that we use to represent a glucose has 24 atoms, and there's a lot of different glucose molecules in starch. So foods you guys would find with starch would be like pasta is a big one, rice, those kinds of things, potatoes. Okay, so you guys have just thousands and thousands of atoms in one of those molecules. Or it could be something as simple as like table sugar, which was sucrose, that has just 2 molecules of glucose. So again, each of those single molecules has 24 atoms, so that means there's 48 total atoms in a little molecule of table sugar. Okay, and then, of course, just glucose itself has about 24 atoms. Anyway, all right, moving on to our next word. Glucose is a molecule that organisms can use to release energy, and that is made up of carbon, hydrogen, and oxygen atoms. And like I said, you have about 24 of those combined. Okay, and oxygen, a molecule that organisms get from the air or water around them and use to release energy. So obviously, we're humans, we're mammals, we're land animals, we have lungs. Okay, so we get our oxygen from the air, whereas something like a fish actually gets it dissolved out of water through their gills. So they don't have any lungs, they soak it through their gills, and their gills pull that oxygen out of the water that's dissolved there. Okay, amino acids are molecules that are the building blocks of proteins. So these would have represented the little color molecules that you did in that little building molecules assignment yesterday. So there's 20 different amino acids, and we can combine those 20 different amino acids in millions of different ways to form all kinds of proteins. And remember, we talked about the shape of a protein kind of dictating what its job is, and if it has the wrong shape, it's not going to do its job. Okay, and that all kind of relies back to what amino acids we have there. Okay, and then finally, key concept number 1, you're going to add to your key concepts page. A functioning human body has molecules from food, glucose and amino acids, and molecules from air, oxygen, and its cells. And that's going to be kind of a little hint for you guys later when you're doing your modeling activity. Okay, so add all of those into your OneNote. And remember, you guys can pause this as you move through. Okay, this is a question from yesterday's assignment. When we eat foods like meat, our bodies digest or break down the protein in the meat in the small intestine. Remember, I showed you guys the meter sticks and said our small intestines were about 7 meters long. And in that first 25 centimeters of our small intestine, that's where most of our body's digestion occurs. Okay, so what building blocks are these proteins broken down to? Or you guys could ask it this way, what are proteins made up of? Okay, when we eat foods like pasta or fruit, our bodies digest, break down carbohydrates. We have 2 types of carbohydrates. We have starch or we have sugar in the small intestine. What building block are these carbohydrates, starch and sugar, broken down into? Again, what are those 2 things made up of? Think of those little white marshmallows. Okay, activity 3, you guys have an article to read, so you guys can right-click this link here and open it up. When you guys are reading, pay close attention to which molecules come in through food and which come in through air, where each of these molecules go and how they may change, and where each of these molecules end up, because your next activity is going to be a little modeling tool where you guys kind of need to organize all these molecules in the human body based on where you guys find them, their pathway through the body, how they might change if we're talking digestion, and then where these molecules end up. Basically, what do we find in the cells of our body? Okay, and I just kind of answered that with key concept number 1. Okay, so right-click that, open up. Your article looks like this, molecule cell needs. So go ahead, read through that. Like I said, might help you guys to kind of highlight a little bit through that just to keep track of these things, because again, you're going to need that information for our next activity. So pause this video, read, look for these 3 key details, and then when you guys are done, you can come on back to this video. All right, so in this little modeling tool today, you guys are going to right-click this link here. You're going to open it up, and you guys are going to be pulled into a picture that looks very similar to what you guys saw in the sim. Okay, the only difference is you guys can interact with this in different ways. So you guys can click and drag. Here's a little key over here to show you guys all the different molecules. Okay, so what you guys might do is say, all right, I'm going to go ahead and take this starch molecule. Starch is something we eat, so we want to put it into our digestive system. And that starch can go down into our stomach, and then it can go into our small intestine, and then when we digest that small intestine, we break it into glucose. Notice how the shape of the molecules that make up starch is the same shape as the glucose. That should be a good hint to you guys that these are the building blocks for starch. So I'm going to go ahead and say, all right, those broke up into glucose, and then glucose is small enough to enter our bloodstream, okay? Starch is way too big, so we would never get starch in our bloodstream because it wouldn't fit across the wall. I really do wish they would have made these about the same size so you guys can kind of see. But remember that starch is generally hundreds of these glucose molecules long. All right, so then our glucose is small enough to break into our bloodstream, so it can go through our circulatory system. It can either be stored in our body, okay, sometimes as fat, or it can go to our cells of our body where we use it for energy. Okay, so I did some modeling for you guys there. I showed you guys where starch is. Okay, really the other thing I want you guys to look at is proteins and amino acids and our oxygen and carbon dioxide. Okay, I'm not too worried about water and fiber for right now. You guys can try to kind of place those if you guys know where we might find them. But the main thing I'm looking for is these 6 things right here. So go ahead and I want you guys to finish completing this model. Okay. Mainly these 6 things. Again, I already did 2 for you, so really you only have 4 to do. So finish that up and then go ahead and screenshot just this colorful square right here. Your guys' instructions to screenshot are on your next slide. Remember to use that article to help you guys if you get stuck. Okay, it'll tell you guys where to find a lot of these things. But if we go to slide 6, here's your little directions on how to screenshot. Go ahead and paste that model in right there. Okay? All right, pause to do that, and then when you guys are ready, let's move on to the next activity. Okay, so this is a little card sort that you guys are going to be doing today virtually. So you get a little message here from the doctor, and we're talking about Elisa. As you know, we are trying to diagnose why Elisa Rodriguez is so tired. We are running some tests on her, and we also asked her to keep journals to record her eating and sleeping patterns. We want to know if the cause of her problems may be lack of sleep or not eating the right foods. We've just received the first set of evidence from Elisa's journals. We need you to evaluate the quality of this evidence to see if it can help us understand what is wrong with Elisa. If the evidence is not high enough quality, we may not be able to use it. So really, what you guys are going to be sorting in this is not so much, what claim we're looking at like we've done before, but how quality is our evidence? Is it something we can use to help diagnose Elisa, or is it just kind of a piece of fluff that really isn't going to help us make an appropriate diagnosis? So here's a question or just a discussion point for you guys. You don't have to answer anything on this. I have 2 pieces of evidence. And I want you guys to tell me which is the higher quality piece of evidence and why. Again, there's nothing you guys need to type to answer this. Notice there's no question mark on this slide. What we see is evidence card A. John observed his 14-year-old brother sleep for 1 night. So basically, he watched his brother sleep. Not creepy at all. His brother slept for 10 hours. Based on this, John concluded that all 14-year-olds need 10 hours of sleep at night. So he says that all 14-year-olds need 10 hours of sleep at night, okay, just from watching his brother sleep from 1 night. Evidence card B, scientists observed the sleep of 2,000 healthy 14-year-olds every night for a month. The average number of hours in the 14-year-old's sleep was 9.4 hours. Based on this, the scientists concluded that 14-year-olds need about 9 hours of sleep a night. So we have John watching 1 person over 1 night, or we've got scientists, plural, observing 2,000 healthy kids. We don't even know if John's brother is healthy, if that's normal. The average number of 14-year-olds was 9.4, so they took these 2,000s, watch them for a couple couple of days and then made an average of their sleep. So we made a conclusion based off that. So obviously, evidence card B is the better piece of evidence because we're watching more than one person. We're watching healthy individuals, so that's going to give us a little bit better look at what a normal, healthy 14-year-old should be doing, those kinds of things. Okay, so with that being said, you guys are going to do that similar thing in the sorting tool, except we're looking specifically at Elisa. So you guys will right-click and open this link up, and then over on the right-hand side, you guys will see all your evidence cards. And you guys will see this gradient. So the better pieces of evidence that we'll see will go towards the top where it's darker. And then the lower quality are down here at the bottom where it's lighter. So if we take a look, evidence card B, the night before she came back to the doctor's office, Elisa slept 7 hours. It might help you guys to just go through and read these first so you kind of can compare them to each other and say, all right, which of these are higher quality in comparison to the other. Evidence card A, Elisa's sleep journal shows that she had gotten on average 9 hours of sleep each night for the past month. So we're looking at more than one day there versus evidence card B. So we might maybe rank evidence card B a little bit higher or lower than evidence card A is going to be a little bit higher than evidence card B just because we're looking at a whole month worth of sleep versus just the night before. Okay, Lisa was asked to keep a food journal for a month. Her diary shows that over that month, Elisa ate between 6 and 8 servings of food that contained starch every day. She ate between 2 and 4 servings of food that contained protein every day. Evidence card D, Elisa ate a lot of starch yesterday, but she still felt tired. And evidence card E, on the day before she started to keep her food and sleep diaries, Elisa said she always felt tired, but she ate well and slept a lot of nights. So go ahead and finish ranking those 5 pieces. I've already kind of done 2 for you, so finish those up. And then you're going to do the same thing that we did with the modeling tool. You guys are going to go ahead and screenshot. You guys just need this little square right here, okay? All right, so screenshot that there, and then moving on, what we're going to find out is this is actually what we're going to compare Elisa's to. So we know a little bit about her sleep from the evidence card and her eating habits. So now let's compare it to a healthy individual. So average teenagers, many scientific studies of teenagers show that most healthy teenagers get between 8 and 10 hours of sleep each night. Eliza's sleep journal shows that she was getting about 9 hours of sleep. So you guys can say, all right, is she getting enough sleep compared to the average teenager? Yes or no? Okay. Average teenage eating habits. A scientific study done on 1,000 healthy 14-year-olds found that they ate between 5 and 8 servings of starch per day and between 1 and 4 servings of protein a day. We found out from Eliza's eating journal or her eating habits is that she ate between 6 and 8 servings of food that contained starch every day and 2 and 4 servings of food that contained protein every day. So do you think she is getting enough starch and enough protein? So think about that one. Finally, you guys are going to go ahead and take a look at the relative size of some of these molecules. So these are all molecules that we're going to be seeing in and around the human body. And you guys will click and move these. So what I want to see, and I'm going to highlight this for you guys so you can get it correctly, is I want the smallest molecules at the top and the largest molecules at the bottom. So your largest one should be at the bottom and your smallest should be up here at the top. Sorry, you can't really see that arrow. Okay, so make sure you guys sort those. If you guys get stuck, which obviously I don't expect you guys to know any of these or all of these, you guys can right-click this little link right here, and it's going to take you into the scale to a link that we used for the microbiomes unit. So remember, you guys can kind of scroll down here. Obviously, we're going to be looking at things that are molecule-sized. So we can kind of click and say, all right, here's a protein molecule. Here's DNA. Here's amino acids. Obviously, if amino acids are used to make up proteins, they should be smaller than a protein. Same with glucose. We know that glucose is used to make starch. So that means we must have starch somewhere here. Oh, look at here. There's our starch. Okay, so go ahead and use that scale tool to help you guys sort these. So you guys can, again, click and drag them to move them. Glucose should be towards the the top because it's small, whereas something like starch should be towards the bottom because it's much larger than glucose as it is made up of glucose. And then finally, do you think these molecules are smaller or larger than a cell in the human body? So you guys will again say, all right, starch. If we compare that to one cell in the human body, how big is that? Use your guys' modeling tool on your sim to kind of think about that. You guys saw something that represents cell in the body, and you also have little molecules that you guys have been strategically placing around the body. So how do those size comparisons look? Okay, once you guys have finished that up, you're going to go ahead and do your wrap-up. Do you have any questions? Circle yes or no. If you have questions, and only if you have questions, you can type them right here. And then 4, 3, 2, 1, how do you think you did on this assignment? You are all done. Don't forget to hand it in. I hope you guys are having a great day, and I'll talk to you soon. Bye.